So in this video, we're going to resolve an integral that requires the inverse secant function. So the integral we have is 1 over x times the square root of 9x squared minus 7 dx. And just like in the previous two videos, we want to start to rewrite the integral to put it into the form of interest. So we have a formula for the antiderivative of 1 over u times the square root of u squared minus a squared. So we want to try to manipulate the integral that we're working with into this form so that we can then apply the formula for the antiderivative to that integral. So I'm going to start to rewrite things. So I'm going to have 1 over x times the square root, and we're going to rewrite the 9x squared as 3x squared plus, pull my radical out, here's my dx, and then 7, we want to recognize that 7 can be written as the square root of 7 squared. So we're going to rewrite that as the square root of 7 quantity squared, and that gives us our a equaling the square root of 7. And then I want a variable squared, but I have 3x squared, so I'm going to do a u substitution here. I'm going to say u equals 3x, and if we do that, then we see that du dx, if we take the derivative with respect to x of both sides, du dx is going to equal 3, or du will equal 3 times dx. And I'm going to do this a little differently than I usually do. Because I have a 3x here equaling u and a 3dx equaling a du, I can actually modify this integral by multiplying by 3 over 3 and get it into a form that's probably easier to deal with than the way that we would typically deal with these. So the idea is if I do 3 times 1 times dx, I have a 3dx in the numerator, and 3dx can be replaced directly with du. So if I start to work through my u substitution piece, I'm going to get 3 times dx can be replaced with a du. And in the denominator, I get 3 times x is 3x, and 3x can be replaced with a u, which will leave me just a u in the denominator, which is what I'm after. And then by my u substitution, I replaced 3x with u, so I'm going to get a u squared. So we get u squared plus, and we have the square root of 7 quantity squared. And now we are exactly in the form that we see right here, so we can go ahead and apply the formula for the antiderivative. So we're going to get 1 over a, but a is the square root of 7 in our example. And then it's going to be arc secant, or inverse secant, the arc secant of the absolute value of u, all over a, but a is the square root of 7 in this example, and we get plus that constant of integration. And now it's just a matter of replacing our u sub that we did in the beginning. So we're going to get 1 over the square root of 7 arc secant of the absolute value of 3x, which was our u substitution, all over the square root of 7 plus a constant of integration. Again, we could rationalize the denominator by multiplying here by square root of 7 over 7 and inside here by the square root of 7 over 7. But again, I don't think there's any particular reason for doing that in this particular instance.